Alright, okay. So let me take that. Okay, what happened is uh, in here it will have 2 over 16. Okay, with respect to your example 7a. Okay, and let's just get the first part. Okay, the first part in here, this is your function f, and this is your f prime. Okay, this is your f, and this is your f prime. So basically, you are already in the form of a7. You are already in the form of a7, which is you have the f prime at the top, and you have the f at the bottom. Okay, so according to the formula of a7, this is supposed to give you a ln f. Okay, so let's just write the next one. So you have 3 over 32. Okay, with this we're going to use the formula of a7. So this gives you the ln 16x squared plus 9. Okay, how about this? Okay, this is back to our example 7a just now. So 2 over 16 will give you 1 over 8. And it will be just x squared plus 9 over 16. Or you can just directly change the 9 over 16 to something in square, just one. Okay, it's in square. So the square of 9 over 16, that is 3 over 4 power 2. Alright, this 1 over 8 is coming from 2 over 16. Alright. Alright, so this is the x. Let me push up a bit on this. Okay, let's just continue the next slide. Okay, so since we already integrate on the first item, we have the second item, and the second item, we're going to use the formula of this again. That is your formula of C1. Okay, so C1 says that you are already in the form of x squared plus a squared. This is your a. Alright, so this is your a. So you're going to use the formula of C7, this 1 over a, x over a. Okay, so let's just continue to the next slide. So we have 3 over 32 ln 16 x squared plus 9 is 1 over 8. So the integration will give you 1 over 8, 1 over 3 over 4. Okay, and arctangent, which is x over 3 over 4, and then plus c. So we almost done. We simplify. So this will give you 4 over 3 and 4x over 3, and simplify some more. This is actually simplified. We will have negative 1 over 6. Alright, okay. So that is the answer for the question of 7C. Alright. Okay, let's look at the last example that we have. Okay, let me push up a bit on this. Okay, look at the last example. Okay, I still need this formula. Let me check out. Alright. Okay, let's just look at the last example that we have, that is 7D. So we have an integrations of x, and it's x squared plus 2x plus 4. Yes. Alright, okay, so what you have here is slightly different from just now. Just now what we have is we have a linear equations, where the linear equation is the combinations of the x and constant. Which is this, you have a linear equations where you have combinations of the x and constant. So when you have that, what you have to do is you have to split into two different equations. One is to handle the x, and one is to handle the constant. But the question D is we only have the x. Alright, okay, so we only have the x. We only have the x, so you don't have to split into two. So when you only have the x, that is the time that you're going to use the formula of A7, that is f prime over f, okay? But okay, let's just look at what is our f prime, okay? So this will be your f prime. This will be your function f, okay? So let's look at our function f. So your function f is x squared plus 2x plus 4. If you differentiate this, okay, we will have 2x plus 2. It means that you need to have 2x plus 2 at the top. But what we have here is only x. We do not have the 2, okay, in front of the x, and we do not have the plus 2. So, but we need to use the formula of A7. Okay, in order to use the formula of A7, we manipulate whatever at the top step by step. First of all, think of adding number 2 next to the x, okay? So just copy the same line again, okay, copy the same integration again. Okay, we have this. Okay, as I said that, just think of to add the number 2 next to x. Okay, just add the 2 here. When you add the 2, you try not to change the questions. So it means that you have to multiply with 1 over 2. Alright? Okay, so if you look at the top, is one step closer to this f prime. Okay? The next thing that you need in the top, okay, at the top, that is plus 2. Alright? So again, okay, we need to add that plus 2. Okay, let me copy the second line of the integration. Okay, so now what I need is the second part. That is, I need the plus 2 here. So I need to put a plus 2 here. So same concept. When I add a plus 2, but I do not want to change the questions. So what I have to do is I need to minus back with 2. When plus 2 minus 2, you actually have 0. When you have 0, it's actually this. So we still do not change the questions. We're still having the same questions. Alright? Okay. And put back the dx. Okay. So let's just look at the next line. Alright? Okay. So now you have the 1 over 2. Okay. So why we want to do that? Okay. For the first two items that you see in here, you put in a bracket. Just put in a bracket. So you will have 2x plus 2 here. Okay, and make sure it's divided by the denominator. Okay, and we have the last item, the third item. Okay, minus 2. So put the minus 2 here, and make sure it's divided by the denominator again. Now it's plus 4. Alright, okay. So in here, what you see here is this one is the form of this f prime over f. This is the f prime. This is the f prime, right? Okay. And this is the function f. We are already in the form of a7. Okay. Let me rewrite it just that it's look nicely. So we have 2x over 2, and this x squared plus 2x plus 4. Okay, let me put the dx. Let me separate into two integrations. Okay, so one is for the formula of a7, a7, and this formula of c1. All right. Okay, so we separate it into two integrations. And of course, we still have the 1 over 2. This 1 over 2 is belong to both rational function. Okay, so we have the minus 1 over 2 integrations of 2. Okay, the 1 over 2 you have to distribute to both items, right? Okay, so now you have two separate integrations. All right, let me push up the 8. Okay, on this. Okay, so now in here, this is the form of the f prime x. Okay, that's this what we want, and this is a form of the f. And according to the formula that we have in here, it says that it's supposed to be equal to ln f. Okay, so directly we will have the answer for the next line, and it will be equal to 1 over 2 ln function f, that is x squared plus 2x plus 4. Alright, for the second item, the second item here in here, we can simplify. Okay, you can simplify 2 and 2 here, and we will have minus 1 over x squared plus 2x plus 4. And again, we're back to a case of constant, and we want to use the formula of C1, and you need to do the completing the square such that it is in the form of the C1. Okay. Okay, let's just look at the completing the square in this part, because we want to use the formula of C1 here. So completing the square. Alright, okay, so we have the x squared plus 2x plus 4. Okay, again, so just copy back the x squared and 2x. Okay, now plus read the coefficient from the x. So plus 2, right? So we have 2 here. Okay, positive 2. And it always have to divide it by 2. And close the bracket and add the square. Okay, so same thing, we do not want to change the question, you have to minus back, so we have same item in here. Okay, so we have the plus 4. Okay, the first three items you can simplify, it become the x. Okay, it become x. Okay, take the x from the first item, and you will have the 2 over 2 is 1. 2 over 2 is 1. You will have plus 1 here. Oh, like this. Okay, let me write another line just that you'll be more clear on this. Alright, okay, so it could be 2 over 2 is 1. Yeah, this. Alright, okay, we're going to apply the same concept. That is the first three items, you're going to simplify it. So this could be simplified as the x. Okay, just take one item from the first. Okay, just take the x from the first item, put it here, and you have the third item, that is 1 square. Just take positive 1. Right? This is a positive 1, so just put the positive 1 here and close with the square bracket. Alright, okay, so the last two items, so we'll give you plus 3. Alright, okay, so that is what you get by using the completing the square. So let's just substitute whatever that we get from the completing the square into here. So we have integrations of 1 over, so this one is this. We just did that. This one is equal to x plus 1 squared plus 3 dx. Alright. Okay. Now, as I mentioned, I want to use the formula of C1, right? Okay, the formula of C1 requires to have the x squared and a squared. This x plus 1. So you have to modify this, and this also you have to modify. This one, how to modify? Okay, this one you can modify by using substitute the u. Just sub the u as x plus 1. So you will have du equal to dx. Alright. 1 over 2. Okay, ln. Alright. Okay, in here we will have u. Okay, and square plus 3. The x is du, right? So we have du here. So we are in the form of C1, but this one again you have to change it. So what is the 3? How to change the 3 to something in square? So we have learned that in class, right? So just have to change the 3 to square 3 and square, right? You still square 3 and 3 and square 3 and square. You will have 3 facts. We do not change the questions at all. But now we are in the form that we can use the formula of C1, and this is your x squared, your x squared, that is your u squared, and we have our a is actually 3. So let's just apply the formula here. So this one we just copy back because we have done with the integration. Okay, so minus of what? We have 1 over a, 1 over 3, tangent inverse. Okay, this is x because we integrate with respect to x. This is dx here. But your questions, your last line, the line here is du. So supposed to change this one to u. So we have u over 3, right? And then close the bracket, and we have plus c here. Okay, and don't ever stop here, because your final answer should not have the u. Okay, change back the u. Okay, where is the u? The u here. Change back the u. Where is the u? That is the u here, which is just now we sub the u as x plus 1, right? So change it back. Change it back. So the u now is x plus 1 over 3. Yeah. So now we have done. Right. See you next class.